Hi folks, Dr. P here. This is Math 10C, Exponents and Radicals. And this video is going to be a review of numbering systems. So this is page 40 in your workbook, topic 5. And on this page, we have this classification of numbering systems. So this is a Venn diagram. Now I'm going to be using this, but I'm going to actually draw it out from scratch. So what I'm going to do is I'm going to see if I can move to the side here. I can move over here, and I'm going to go through this diagram and sketch it out. Okay, so on the outside we have this rectangular box that's going to be representing real numbers. Okay, so real numbers are all numbers that we would encounter in this course. Real numbers can be then split up into different types of numbers. But in this course, any number that you will encounter will always be a real number. And real numbers are often, the symbol for real numbers is often, the one that's used is often a R, but it's sort of like a bolded R that's often written like this when you write it by hand. Okay, so these are real numbers. Now, real numbers are split into this, right? Real numbers are split into rational and irrational numbers. I'm going to draw this oval here and try and do this somehow somewhat neat. Okay. So on the left-hand side, we're going to have rational numbers. And rational numbers are often represented by a capital Q. And on the right-hand side, we have irrational numbers. And irrational numbers are often represented by a Q, capital Q, with a bar above it, or just Q bar. Okay, the way this is read is Q bar. What is the difference between rational and irrational numbers? Okay, so rational numbers, let's do a definition here. Rational numbers. So rational numbers are numbers that can be expressed as a quotient or a ratio. So they can be or you can think of it as a fraction. So they can be expressed as a fraction. Okay. And the characteristic that rational numbers have is that they are what's called terminating, if they have decimals. So terminating. Decimals. Terminating decimal part, which essentially means that if they have decimals, the decimals don't go on forever, they stop. Okay, so for example, 1/2 would be a rational number because it is written as 1/2 because it's written as a fraction. If we divide 1/2, we're going to get 0.5, and that's it. There are no further decimals here. It's a terminating decimal, so it's a rational number. They are terminating decimals, or they are repeating decimals. So an example of this would be 1/3. So this is written as a fraction, so clearly that alone will tell you that this is a rational number. But if we divide 1/3 on our calculators, we're going to get 0.333, and so on and so forth. We can write this as 0.3 with a bar above the 3 to indicate that the 3 is repeating. So the decimals, the 1/3, 0.3333, is not a terminating decimal. These 3's go on forever, but they are repeating. Okay, so as long as we have either terminating decimal part, or if it's not terminating, the decimal part is repeating, there's a pattern in the decimal part that's repeating, we're talking about rational numbers. Okay, so irrational numbers cannot be expressed as a fraction. Okay, and the characteristics that they have are that they do not have a terminating part, decimal part, so the decimals continue forever, and there are no patterns in the decimal. So no terminating decimal part. And no repeating patterns. So an example of an irrational number would, for example, be the mathematical constant pi. Okay, so pi is approximately 3.14, but as we all know that those decimals, they continue forever and ever, so they're not terminating, and there are also no patterns in the decimals. It just appears to be random. Okay, so that's the definition of rational and irrational numbers. The rational numbers can be further divided into integers. Integers here. These are integers. Okay. And integers are often denoted by capital I. Okay. So integers are positive and negative whole numbers. Okay. So for I, for the bolded I, so integers are positive and negative whole numbers, so no decimals. So for example, -2, -1, 0, 1, 2, and we can go on both towards positive infinity as well as negative infinity on the left. This will be integers. Integers in turn can be divided into or subdivided into whole numbers. Okay, whole numbers are often indicated using a capital W. Okay, whole numbers include the 0 but not the negative numbers, so they are includes 0 and positive whole numbers. So for example, or it will be starts with 0 and then we go with 1, 2, 3, and then we go on, but no negative whole numbers. And then finally, whole numbers can be subdivided into what's called natural numbers. So I'm going to have to do this on the side. this here is, these are natural numbers. And natural numbers are often denoted with a capital N. And natural numbers are what's called countable numbers. So numbers we use to count things with. So 1, 2, 3, 4, 5. So it's going to be positive whole numbers. It does not include 0 anymore. So 1, 2, 3, and so on. Okay, so that's the classification that we're using here. And I'm going to leave it at this. There are examples in the book, so in the workbook. So next page, back there. On the next page, on page 41, you have this table where you get to classify numbers based on the set that they belong to. And that's going to be a wrap. So until next time, stay safe, stay healthy, and may the math be with you. See ya.